All right, guys, in this lesson, we're going to talk about the difference between parallel and perpendicular lines. Okay, before we get into this, the most important thing to know between parallel and perpendicular lines is what they actually look like. Okay, what do parallel lines look like? Okay, what you need to know about parallel lines is basically that they're two different lines that are never going to touch. If we look at this example below here, notice how this line keeps going down at the same angle forever and ever, and the line right next to it basically looks like a mirror image of it, but it's never ever going to touch the line that's to the left of it. Okay, what do you need to know about parallel lines? Parallel lines never touch. They never cross paths. Okay. The opposite of parallel lines would be what we call perpendicular lines. Okay, these two lines definitely intersect, but they intersect in a very unique way. Okay, they intersect at what we call a 90-degree angle. Okay, it is a perfectly straight angle between here, between the line that's going up and down and the line that's going left to right. Okay, what do you need to know about perpendicular lines? They intersect at a 90-degree angle. Essentially, they make a perfect L when they cross paths. Okay, now let's compare the equations for each of these types of lines. Okay, parallel lines, obviously, you're going to be dealing with two different unique equations for lines, but if you're dealing with parallel lines, you need to know that the slopes are going to be the exact same. The slopes for parallel lines are going to be the exact same, but the intercepts are going to be different. Okay. The y-intercept could be whatever you want, they just can't be the same number as the other line. Okay. In comparison, perpendicular lines have what we call opposite and reciprocal slopes. Okay, we've talked about this before. And then going off of that as well, for parallel lines, the y-intercepts had to be different. For y-intercepts, for perpendicular lines, we'll just say they are not important. Okay, they could really be whatever numbers you want. Okay, so if you have perpendicular lines, here's what you're looking for. You want the slopes to be opposite reciprocals. If your first line has a slope of 1/4, the line that is perpendicular to that one will have a slope of the opposite reciprocal. So when we do the opposite reciprocal, what's going to happen here is the numerator and denominator are going to flip. So it'll be 4/1, but it's also going to be the opposite sign. So the first line had a slope of positive 1/4, which means the slope of line 2 is going to have an opposite sign. It'll be -4/1. Okay. So an example below and above, we'll kind of jump back and forth a little bit here. It's semi-difficult to tell what the slope is, but for the slope of line 1, it'll basically have a rise of 5 and a run of 1. I know it's a little bit difficult to tell because the picture is not super clear, but it has a rise of 5 and a run of 1. That means the slope of the first line is 5/1. And because the lines are parallel, we know the second line is going to have the exact same slope. It'll be 5/1 as well. Parallel lines have the same slope. That's the biggest takeaway over and over again. The slope of, or the y-intercept of line 1 was 0, and then if you look at the graph, the slope of the intercept of line 2 was equal to 6. Okay, doesn't really matter what these numbers are as long as they're not the same. Same slopes, different y-intercepts are parallel lines. Okay. In the perpendicular example above, we ultimately discover that this line that goes straight up and down has a slope of 5/1. And the y-intercept, we called it about equal to 0. Okay. The line that goes a little bit more horizontally, that line that goes left and right, it's going to have an opposite reciprocal slope. Okay, so what does that mean? What I'm going to do is I'm going to flip that slope. So instead of 5/1, it's going to be 1/5. And then it's going to be the opposite sign. So instead of positive, it's going to be negative. And the slope of the second, or the y-intercept of the second line happened to be -4, but like we said, it's not that important. Okay, so let's do some examples. So the question is asking, are the lines parallel, perpendicular, or neither? And we've got two different equations for a line. We have 4y is equal to negative 5x plus 12, and the second line we have is y is equal to 4/5 x minus 8. Okay, in order to tell if the lines are parallel or perpendicular, we have to find the slopes of both lines. Find both slopes. Okay, what's nice is if we look at line 2, y is equal to 4/5 x minus 8, we already know the slope of that second line. Because it's in slope-intercept form, it's in that format y is equal to mx plus b. We can already tell the slope of the second line is 4/5. Okay, now all we got to do is we got to figure out the slope of the second one. We want this equation to look like y is equal to mx plus b. Okay, it's not like that yet. Y is not by itself, so we got to get y by itself. We see 4 times y is equal to negative 5x plus 12. What do I have to do to get y by itself? I got to divide my entire left side by 4 and my entire right side by 4. Okay, watch what happens here. The 4 cancels with the 4, and I'm just left with y. And basically, each of these pieces is going to be divided by 4. I'll have negative 5x divided by 4 plus 12 divided by 4. When I clean this up a little bit, we know that 12 divided by 4 is equal to 3. When I have my nice equation for the first line, it should come out like this. Negative 5/4 x plus 3. This is the equation for the first line in slope-intercept form. So what do we know? We know that the slope of the first line is equal to negative 5/4. So now that we have the slopes of both these lines, all we got to do is compare them. So we notice that they're not the same, so they can't be parallel, but because the slopes are opposite reciprocals, different signs, as well as like the inverse, 5/4 and 4/5, that means these lines are going to be perpendicular. The slopes are opposite reciprocals. These classify as perpendicular lines. Super simple. If you're trying to determine if lines are parallel or perpendicular, just find out what the slopes of each of the lines are.